Now I figured it'd be a good time to cover validation layers, because the code we ended with in the last video has some issues to it, and your triangle might have not shown up at all. So I'm going to build and run. Actually, I'm not going to build and run. I'm going to do a git diff. And we can see some of the changes that I made here. You can see I added this char pointer array, and we added the VK layer Chronos validation, added a few extra members, or changed some members to the VK instance create info. And then I have VK create instance right here, and just an error message that can show up. So let's build and run now. Then let's see what happens. So you can tell we're getting all of these errors, mainly having to do with, you can see semaphore and fence are both VK null handle. And I think there might be some other errors in here as well. So this is the great thing about Vulkan as opposed to something like OpenGL, is that you can get some great error messages. I know that sounds weird. Well, why would you like error messages? Well, the reason why it's good is because if something goes wrong, it's much easier to tell what's going wrong because of this. In Vulkan, there's different kinds of semaphores. So there's binary, and there's, I believe, timeline semaphores. We're going to use binary semaphores, which has two states, either like signaled or unsignaled. And in semaphores, they can have a payload. And if I'm reading directly from the documentation here, it says the internal data of a semaphore may include a reference to any resources and pending work associated with signal or unsignal operations performed on that semaphore object, collectively referred to as the semaphore's payload. And there's something we're going to want to change in the code we have right now, is this VKQ wait idle, which technically just kind of freezes the CPU and it makes it wait to finish everything before we do something else. So we're going to switch this out and do something else. And another issue we have with our code, we can see this error message here. It says that VK destroy surface kchar called before its associated VK swap chain kchar was destroyed. So let's see what we can do about that. And I'm going to change this code a little bit. So what I'm going to do is, instead of having a while loop, just to make it a little bit easier to look at error messages, I am going to, well, first, to fix the swap chain issue, I'm going to add this VK destroy swap chain kchar at the end of free swap chain, like that. And then I'm going to get rid of this. I'm going to get rid of this as well. I'm going to keep draw frame here, but I'm going to add a sleep right after this so we can see it, and then it disappears and we don't get a bunch of different error messages that are pretty much the same error message. And I'm actually going to change my makefile again. I don't have to use C89, so I'm actually just going to kind of do one of these. And actually, I'll just comment it out so that when I make and run it, it's not going to have any issues here. So let's get rid of that, And you can see here, I'm adding a sleep, and I think it's probably sleeping for a little while. Let's sleep. Is that milliseconds? I don't remember. Man, sleep. It's in seconds. So yeah, let's not do 1,000 seconds. Let's do 1 second. Let's make and build and run. Implicit. So let's see why it's implicit. What do we need to do? Man, sleep. What do we need? Uni STD. And this is, Linux specific. Uni STD. We have that. We have our sleep. Let's make clean, then let's run. Oh, I accidentally closed my terminal, but let's try this again here. And then run. And you can see, look at, we only get one error message, much easier to look at. Let's work on adding our semaphores. We have my two global variables, our image available semaphore and our render finished semaphore. We're also going to be using fences. So fences are a synchronization primitive that can be used to insert a dependency from a queue to a host, just reading directly from the documentation again. Fences have two states, signaled and unsignaled. A fence can be signaled as part of the execution of a queue submission command. Fences can be unsignaled on the host with VK reset fences. Then fences can be waited on by the host with the VK wait for fences command, and the current state can be queried with VK get fence status. We are also going to add our VK fence global variable, and we're going to create the fence. But before we do that, I'm just going to show you here and display the differences between unsignaled and signaled fences. So, unsignaled says stop wait. If the CPU calls VK wait fence, it will hang there until the state changes. And then a signaled fence will say, go. If the CPU calls VK wait fences, it will return. It returns immediately because its work is done. So just so you can see the differences between signaled and unsignaled. So here you can see the function we have to create our fence, and you'll see that right away we make it signaled, and we give it the one fence, the in-flight fence. We also have a function to create and destroy our semaphores, and we have two semaphores. We have the image available semaphore and the rendered finished semaphore, because we're going to have to wait for two different things. So in the image available semaphore, it's going to be signaled by the swap chain, and then it's going to wait for the graphics queue. And the rendered finish semaphore is going to be signaled by the graphics queue, and it's going to wait for the present engine. Next, we're going to change our draw frame function. For the first line of the function, we have this VK wait for fences. And what it's going to do is it's not going to continue with the rest of the function until in-flight fences is signaled. Then once we see it in the signaled state from the wait for fences, we're going to do a VK reset fence, which is going to immediately put it back to the unsignaled state. Here in VK acquire next image KHR, what we're going to do is we're going to get the image index here like was doing before. And we're going to have our image available semaphore here as well, which what that's going to do is it's going to wait for the image to be, it's going to wait for the image to finish being displayed. And then once it's finished being displayed, it'll, signal the semaphore. So it's saying, so here it's going to be signaled if the presentation engine has finished reading from the image. And if you remember before, when we created our fence, it was already signaled, and that's because we would have never been able to get into this draw frame or start the rest of the draw frame function if it didn't start signaled, because of the first VK wait for fences, which checks to see if in-flight fence is signaled. You can see that we changed our submit and present struct. We have image available semaphore for the p wait semaphore member, and rendered finish semaphore for the p signal semaphore member. We have our in-flight fence for the fence for VKQ submit. We have rendered finish semaphore for p wait semaphores, and yeah, that's what we changed here. And here I have a timeline of when things get signaled and unsignaled. I changed our validation portion of the code a little bit. And here further down in main, we, we call our create sync objects, we call our create semaphore, and we also make sure to destroy our semaphore. We make sure to destroy the fence. And let's switch this around again so that we can get rid of sleep. Uncomment out this part of the code. Build and run. And it seems like we're getting no errors. That'll conclude the video for now. Hope you enjoyed.